Hi everyone, welcome to our lesson on acids and bases. I'm going to start with this idea that acids are molecules which donate hydrogen ions, which we call protons, and bases are the molecules that accept protons. So using that idea, and by the way that's a Bronsted-Lowry definition for acids and bases, we're going to look at these two molecules and we see that this one has the hydrogen ion that ends up on this molecule. So this donated a hydrogen to this molecule, becoming H3O+. So in terms of my definition, this is my acid because it's a hydrogen donor, and water is my base because it's a hydrogen acceptor in this case. Now let's look at what happens. Over here we have now the water molecule that has a hydrogen is now the donor for this hydrogen, potentially donating it to Cl- to go the opposite way. So this is a reversible reaction. In the case that it reverses, this is acting as our donor, so this is our acid, and then it would donate to Cl-, which would then be our base. Now there's a relationship between this particular acid and this base with this acid. That is that this acid molecule HCl becomes Cl-, this base water becomes hydronium ion. So these are what we call conjugate pairs. So sometimes you see HCl being called an acid, chloride ion being called its conjugate base of HCl. So I'm going to put conjugate base, meaning conjugate base of its paired acid, CHCl. And then these two are paired, so I'm going to call this my conjugate acid of the base that I started with. And I'm just going to put conj as an abbreviation for conjugate. Now I want to talk about the curved arrows. We've talked about this with resonance structures, and it applies to chemical reactions as well. Can you see what's going on here with these arrows? So we usually originate from electrons that are willing to bond, so usually lone pairs. And so this lone pair is being used to grab this hydrogen, and that's how we make this bond right here. So that's our new bond. This is from the lone pair over here. We have this lone pair still there, and then this hydrogen breaks off of the HCl. So we start an arrow from the middle of the HCl bond and draw it toward the Cl as an acceptor. So the Cl had 3 lone pairs and now it has 4. I guess maybe you might think of it as being the pair that are right here. So the curved arrow from water to the HCl represents a bond formation where this bond is being formed. And this bond is breaking and giving its 2 electrons to the Cl. So that's what we call bond cleavage. Chlorine in HCl has 3 lone pairs, and as a product it has 4. So that came from the bond cleavage, the 2 electrons in the bond. For practice, let's look at these problems. I want you to draw the lone pairs, and I want you to determine, based on what products you see, who is the donor and who is the acceptor, meaning which is the acid, which is the base. Draw the curved arrows and show the formal charges. Label your conjugate acid and base as well. Go ahead and give that a try, and it should look sort of like this, where we had everything labeled and the arrows. What I'm going to do is notice what happens to the hydrogen. So here's my OH, and it's still OH here, but I see this hydrogen up here is now gone in this product here. So it ended up going to the OH. So we don't draw the H going to the OH though, we draw it the other way around. We start with the base, we draw the arrow from negative charge, the lone pair, being used to grab the positive hydrogen, and then the bond breaking and depositing a lone pair on the oxygen. So here's my acid is the donor, my base is the acceptor, my conjugate base came from my acid, and my conjugate acid came from my base. Therefore, if the reaction reverses, which it is a reversible reaction, I'm going to have my base grab my hydrogen and go backwards. For part B, what I'm noticing is that this hydrogen gets transferred from this molecule here to this molecule in this position there. So if just sort of looking, this goes onto the O. But we don't draw our arrow that way. We start with the base. The electron charge is negative here, going toward a more partially positive hydrogen, and then that breaks off and we make neutral water. So my arrows go from base to acid, then bond breaking after the bond formation. So this time they're telling you what your acid and base are. So this is my acid and this is my base. And they want you to use the arrows and figure out what the products are going to be and then label your conjugate acid and base. Remember that the curved arrows start with the base, okay? And you have a bond formation and then a bond cleavage. Go ahead and give it a try and let's check our answers. Alright guys, so here are the answers that I get, and notice that I started my arrow with the base and I grabbed the hydrogen, then I showed you where the hydrogen ended up. So these are all proton transfer reactions. Then I labeled my acid becoming a base, so that's my conjugate base, and my base becomes the conjugate acid. In the next example, I have hydroxide grabbing a hydrogen. This bond breaks, so my conjugate acid base pair are hydroxide and water and hydroxide. And the last example, I have the conjugate base of sulfuric acid, HSO4 sulfate ion, and it's grabbing a hydrogen ion from hydronium, releasing water. So here's that, and this is my conjugate acid and my conjugate base. So the next question for you so here you might notice, oh, this is sulfuric acid, H2SO4, and that's a strong acid. So is it likely that we're going to be making a strong acid? They like to dissociate their hydrogens. So the next question for you is to wonder, what side of the reaction is favored? Is it likely that this reaction will occur, or will it prefer to go in reverse? And actually we're going to need to figure that out. So that's for the next video.